Good morning, everyone. I just give you back the exam 2. So exam 2, the highest score is 96. The lowest score is 60. The average is about the same. We have 3 students get A, 2 students get B, and 3 students get C, and 1 student get D. Okay. So I would say compared to last time, one of you didn't do well. Okay. So I hope, what is our goal? I want everybody can pass this course, so you can stay with me in Applied Calc 2. Okay? So try your best to study, and please come to see me if you want to improve your grade. Do you still use the practice exam to as a study guide and do your homework and then figure out how to do those problems? Yes. So continue with that. We still have, let's see. I think we have 4 exams and 1 final. So let's see. Let me insert. Oh, I cannot insert here. So the table is a little bit wrong. You have another exam 4, okay? And you can use the final exam to replace the lowest chapter exam scores. So if you didn't do well on one exam, that's totally fine. You can use the final exam to replace that. But promise me, you need to study harder. Okay? Yes, try your best. Okay, so let's continue. So this is the schedule. So today is Friday, October 27th. So today we will finish 5.3 and then we will start 6.1 and 6.2. And do you remember, because I changed our schedule, and that's why the next month you're gonna be very busy. And next week you have 2 homework assignments due and you have a quiz 4. Okay, everybody? Yeah, so we postponed some of the homework and quiz. That's why. Hi, Leila, come here and pick up your exam. Okay, yeah, so we postponed the homework and quiz and the exam. That's why this month you're gonna be very busy. So next week you're gonna turn in homework 6 and homework 7. Is that clear, everybody? Yes. If you need help, come to see me. Come to my office. Ask me questions. So, okay. And are you okay with the homework? Sometimes you look at the sample homework solutions and figure out the way how to solve the problems. Are you able to do that? If you don't understand some problem, please feel free to come to see me. And when is our next exam? After 2 weeks. Okay? So exam 3 only covers 3 sessions. Okay, everybody? So please also do the practice exams. And oh, by the way, I give you back the exam. And so this is on the website. Do you see here exam 2 solution is right here? So you can look at the exam 2 solution and then write down the corrections next to your mistake on your exam. Okay? And then take pictures, combine into a PDF, and submit it here. The self-assessment. So I didn't grade your practice exam 2, but if you haven't submitted your practice exam 2, please submit it as soon as possible. And then exam 2 correction and exam wrapper is right here. So exam wrapper is the same as before, but your mistake might be different, so you can change a little bit. Yes.
What if you miss the first wrapper? Could you still?
Yeah, you can still turn it in. Right. I still expect that. So I set the setting to be unlimited attempts. So if your score is not 10 points, that means you missed something. You can resubmit to get the points back. So I hope everybody, your homework, you get perfect scores for your homework. That's 5%. And also the self-assessment, you can get perfect scores. Because the practice exam and exam correction and wrapper, you just do it. Then you get full credit, right? So if you miss something, you can resubmit and gain the points back, right? Okay. So this is the solution of exam 2. So I already posted. Okay. The problem 1 is find the derivatives. So you have combination of chain rule, product rule, quotient rule. Some of you, when you do chain rule, forgot to multiply by u prime at the end. Chain rule multiply by u prime at the end. Okay, and the derivative of ln of x is 1 over x. Okay, it's not 1 over ln of x, it's 1 over x. And here also chain rule, product rule, quotient rule, and chain rule. And then this one, find the tangent line. You find the derivative. And remember, when you see 5 over x, change it to the standard form. So write it to the standard form first. Then take the derivative. Okay? The slope is x prime of 1. But the y coordinate of the points is f of 1. Okay? Some of you forgot to find the y coordinate. That is f of 1. So the point so far, y minus the y coordinate equals the slope times x minus the x coordinate of the point. Okay, so look at the solution and then make corrections next to your mistakes. Okay, problem 3, almost all of you get this. And problem 4, okay, problem 4, part A, find the average rate of change. So this case, V is the investment in millions of dollars. Do you see V is money? Do you see this is capital V, not small v? So this is not displacement, velocity, or acceleration. No, this is not about distance or one-dimensional motion. Okay? This is about money. So average rate of change is change of the quantity over change of times. That's why many of you lose this 5 points. And many of you take the derivative here and then take the second derivative here. No, we're not talking about acceleration. Don't take second derivative. Your instantaneous rate of change is the derivative. Okay, everybody? So so some of you, not small, it's many of you make this mistake. So I wonder, how did you do on the practice exam? So on the practice exam, let's see. Okay. Yes. So this is the practice exam. It talks about average profits and marginal profits. And because here the x is the number of items you produced, but the problem on the actual exam, your independent variable is the time. Okay? That was a little bit different. And let's see here, right? This one we take the derivative. Okay. Yes. So that's a little bit different. Okay. Oh, attendance. Thank you. Okay. Let's see. Right. And then, oh, this one is similar, right? You have the profit, okay? This is the profit function. And the marginal profit is the derivative of it. So I think the problem is like this one, right? You have, in your practice exam, you have revenue, and your marginal revenue is the derivative of the revenue. Okay, everybody? So marginal profit is the derivative of the profit. Okay, and then this problem. Okay, this problem. Yes, questions? This is the average profit, not marginal profit. Yes, because you're over x. Marginal is derivative, instantaneous rate of change. Yeah. Okay, so this one, some of you forgot to take the derivative. This is p of x. We're looking for p prime of 7. So you need to take the derivative first, then plug in the 7. Look at your practice exam. See, this is your practice exam. It's kind of similar, right? Take the derivative and then plug in. Some of you have mistake on the last problem. When you take the derivative, you have x prime and your inner function stay here. You multiply by your inner function derivative. Okay, everybody? So please look at the solution and then make the correction next to your mistakes. So this is how we learn and how do we improve. Okay. Yes. Okay, so right. Let's continue on session 5.3. Okay, example 4. So I asked you to do example 4 last class. And I think many of you got the derivative, right, everybody? Do you get your derivative is 12x cubed minus 12x? So you factor out the 12x, you get x squared minus 1. And then x squared minus 1, you can factor as x plus 1, x minus 1. Oops, I mean multiply. And you set this equal to 0. You get the roots are 0, negative 1, and positive 1. Do you get that, everybody? And then the second derivative, did you get 36x squared minus 12? And the common factor is 12. You get 3x squared minus 1. Right, everybody? You set this equal to 0. Then you get 3x squared minus 1 is 0. You get 3x squared equals 1. And x squared equals 1/3. But when you take the square roots, you need to put plus or minus. Right, everybody? Do you get 2 roots plus or minus 1 over square root of 3? Yeah, And now, let's see our domain. Because this is a polynomial. Remember domain? We tried 3 things. What is the first thing that has restricted domain? Denominator is the second thing. What's the first thing? Fraction. A fraction is the second thing. The first one is the square root, right? The second is the fraction, or the denominator cannot be 0. How about the third one? ln, yes, ln. The things inside the ln must be positive, right? In this case, we don't have any of those. That's why the domain is all real numbers. So all real numbers. Okay, right? So this is first step, second step, and the third step. We draw the real number line separated by those critical points. Okay, so minus 1 and 1, and then minus 1 over root 3 and 1 over root 3 here. Yes, draw a longer line. So minus infinity to minus 1. Here, minus 1 to minus 1 over root 3. Negative 1 over root 3 to 0. 0 to 1 over root 3. 1 over root 3 to 1. 1 to infinity. Yes. Do you see this function? The roots are so symmetric with respect to 0? That is because this polynomial, do you see the power of the degree? Okay, is 4, and this x power is 2. They're both even numbers. Okay, when you see even numbers powers, the function will be an even function. Remember even functions, they are symmetric with respect to the y-axis. That's why the answer, you can expect the answer here is going to be symmetric to the answer here. Okay, everybody? This is an even function. Just by looking at the power, we know this is an even function. All right, let's see. Remember, we draw a bigger table. So you have f prime, and f, right, everybody? And for for f prime and f prime prime, you want to answer whether it's positive or negative, or if it's 0 or does not exist, right? But for f, you want to answer, remember I said the circle and then you cut it into 4 pieces? Uh-huh. And depending on whether the function is increasing or decreasing or pointing up and pointing down, then you draw one of those 4 pieces. This is the actual shape of the graph. Okay, right, everybody? Yes. Let's see. Pick some test points. Okay, well, what test point do you pick from here? What number is on this interval? Negative 5. Yes. Oh, by the way, how about we write down the roots? So f prime, for the roots 0, -1, and 1, we get 0, right? So we put 0, 0, and 0 here. F prime prime at 1 over square root of 3 and negative 1 over square root of 3, we get zeros. Okay, everybody? So yes, here we take negative 5. And then we plug in the original form, or we plug in the factor form. Factor form, right? So we don't need to use calculator. Okay, negative 5 is negative. How about this? Negative, this? Negative. So 3 negative multiply, we get negative. Yes. So this we get negative. Right, everybody? And do you see these 3 things? So this interval, this number, and this interval, they will be the same sign. Okay, because the root is -1 and 0. So these guys will be the same sign. You don't need to pick 3 numbers to plug in. You only pick 1 number from this range. So -1 to 0, what number do you pick? Negative 0.5, right? Oh wait, Dylan, if I plug in negative 0.5, this is negative, this is positive, this is negative. So together is positive. Yes. So we have positive, positive, and positive for the 3 regions. Right, everybody? Okay, Paige. Do you see the roots are here? So these regions will have the same sign. So let's see. What number do you pick here on this region? From 0 to 1? 0.5. You plug in 0.5. This is positive, this positive, this negative. So together is negative. Yes. So we have negative, negative, negative. Okay, everybody? Mackenzie, what number do you pick here? 2. And then this is positive, positive, positive. Together is positive. Good. Okay, this is f prime. Now we look at f prime prime. F prime prime. Do you see the roots are these 2 numbers? Plus or minus 1 over 3, right? So which means this region, this number, and this region will have the same sign. Yes, everybody? So if it's the same sign, I suggest you can put a box here. Then you can remind yourself, oh, these numbers, same sign. These numbers are same sign. So you're not checking what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're not checking 11 things. Okay? You're checking 3 things. Okay, everybody? So drawing the boxes can help you to understand, oh, they will have the same sign. So I have less things to check. Okay. Gabby, what number do we pick here? -1, right? You can plug in the factor form, right? Actually, you can factor further, but if you factor further, you get √3x plus 1 and √3x minus 1. Okay, so you get the irrational number as coefficients. So you can put in here or put in the more factor form. Up to you. So if we plug in here, -1. -1 squared is positive. So 3 times 1 minus 1 is positive. So we get positive and positive and positive. Don J, what do we plug in here? What number do we plug in here? 0. Then what do you get? Negative. Yes. Negative. So all those three regions are negative. Okay? Joseph, what number do we plug in here? We get 1. So when we plug in 1, we get, what happened? Positive. Yes. Okay. Bless you. Now let's see. Everybody look at this circle. You cut it into 4 pieces. Think about pizza. You cut it into 4 pieces. Later. So look at this part. Your function increasing or decreasing? Decreasing. Concave up or down? Up. Decreasing and concave up. Which one? Left or right? Up or top and bottom? Bottom left. Exactly. So we draw the actual shape here. Like this. Okay? Everybody make sure you don't draw parentheses. Because parentheses is not even a function. Right? Your function must pass through the vertical line test. If you draw a parentheses, this is not even a function. Okay. Yes. Wheel again. This part. Increasing or decreasing?
Increasing.
Increasing. Concave?
Up.
Up. Then which one?
Bottom right.
Bottom right. Exactly. Very good. The bottom right looks like this. Dylan, how about this? Increasing, concave down, which is, yes, top left. So top left. Good. Paige, how about here? Decreasing, concave down. Which one? Decreasing, concave down. Which one? Left or right? Top or bottom? Decreasing and concave down. Top right, yes. Top right. Okay, Mackenzie. Which one? Bottom left, yes. Gabby. Yes. Okay, good. Now, do you see this picture? Decreasing and increasing. What do you say at this point? Yeah, local min. How about here? You increase and then you change concavity. So this is a inflection point. See, it's not local min or less, but it's an inflection point. It changed direction, right? Inflection point. How about this one? Local max. How about this one? Inflection point. And then this one? Welcoming. Yes. Okay, now we go to step 4. So step 4, we plot the important points. Right, everybody? So the important point, they are -1 and -1/√3 and 0 and 1/√3 and 1. Right, everybody? We have 5 important points that we need to plot. Okay, what's the function? Okay, right there. If we plug in -1, what happened? Dangje? If we plug in -1, what happened? Yes. 3 minus 6 is, yes. Good. And Joseph, what happened if we plug in -1/√3? So what is -1/√3 to the 4th? By the way, the negative square is positive, right? Mm-hmm. To the 4th, you can think of it as like square and then square. The √3 square becomes 3, then 3 square becomes 9. So this is 1/9. Okay? -6 times square. √3 square is 3. Yes. So that's why we got, 3/9 is 1/3. And 6/3 is 2. Oh, what's this number? -5/3. Yeah. Okay, Layla, what happened when we plug in 0? Yeah. This is easy, right? And everybody, do you see, because this is an even function, so the f of 1/√3 is also -5/3. Right, everybody? And f of 1 is also -3. Good. And then we can draw the picture. Okay, let's draw the picture. Let me make it smaller. Okay, so we have the x-axis, the y-axis, plug in the important point. At -1, we get -3. That's here. At -1/3, maybe no, 1/√3, we get -5/3. You know, -5/3 is between 1 and -2, so it's about the -3. Right, everybody? Yeah. So your number don't need to be exact. You just put a bar there and say that is -5/3. You don't need to put a lot of bars. Oh, this is -1, this is -2, this is -3. You don't need to do that. Okay. And also 0, we get 0. Okay. 0 gets 0. And 1/√3, we also get this number. And 1, we get -3. Okay, so we plot those important points. And then we copy and paste the shape. Right, everybody? So, the shape like this. So you put this down here, copy and paste, you get something like this. Do you agree, everybody? And then, okay, next one is this shape. I copy and paste here. Okay, so it looks like this. Right, everybody? Next, it looks like this. Right? This one, I copy and paste here. By the way, Don't draw me line segment. Don't draw me this. Polynomial is very smooth. Don't draw me line segment because I need to tell whether the function is concave up or down. Okay? If you draw me a line segment, it's not differentiable and I cannot see the concavity. Okay. Next one, decreasing concave down. So let's see, like this. Oh, okay, let me draw better. Okay. Hi, how do I draw better? Let me find a good shape here. Okay. Okay, this is better. And then that. And then that. Oh, my bad. I cannot go back. Okay. So, erase this. Okay, it should be goes oops. I don't mean to erase that. Okay, give me back. Okay, here. Ooh, like that. So this is a graph. Do you see it's symmetric with respect to the y-axis? Yes, because this is an even function. It's supposed to be symmetric with respect to the y-axis. Okay, so this is the 4 steps how to sketch the graph of a function. Everybody clear? Mm-hmm. Yes. All right. So let's keep going. Okay. Next type of problems we talk about. Okay. Do you remember before we talked about when a function is continuous? So you were given piecewise function. You were looking for some number such that the piecewise function is continuous. And then we want to make sure the left side limit and the right side limit agree. So then your function is continuous everywhere. Okay? So here, example 5. We're going to have 2 parts. So you have 2 parameters A and B. Part A, you want to find the numbers, the values of A and B, such that the function is continuous. And then part B, you want to find the numbers A and B such that the function is differentiable. Okay, everybody? Do you remember differentiable is stronger than continuous? Mm-hmm. Differentiable implies continuous. Right, everybody? And it is not continuous, then it's not differentiable. And there are 3 types of non-differentiable. Do you remember? The first type is when you have a corner, right? Your left side derivative and the right side derivative does not exist, so your slope does not exist at that point, right? And then the second type is when the function is exactly not continuous. So you can have a removable discontinuity, you can have jump discontinuity, you can have infinite discontinuity, you can have exponential discontinuity. Then it's not differentiable. The third one is when you have a vertical tangent line, right? If you have vertical tangent line, your vertical line, the slope is not defined. So that's why the derivative does not exist. Okay? So 3 types of non-differentiable cases. Okay. All right. So that's why part A is something you did before in exam 1. Okay. Do you still remember exam 1? You check the left side limit and you check the right side limit. You set them equal and you solve for the parameter, right? And you also need to mention the limits equals to the function value at that point. Because to be continuous, you need to satisfy 3 conditions. First, the function is defined at that point. Second, the limits exist. It means the left side limit and the right side limits agree, right? The third, the function value equals to the limits at that point. So 3 conditions you need to check. Okay, let's do that. All right, so let's see. Maybe you want me to write down, okay, f is continuous at x equals a, 3 condition. F of a is defined. Limit x goes to a, f of x exist. That means the left side limit and the right side limit agrees. Okay, and the third one, you need the limit equals to the function value. Okay, so that is definition of continuous at a point. Okay, so now for this problem, let's see. We have two p's. Look at this piece. Do you see the ln and whatever they are continuous on the domain, right? So this piece is continuous, and then the other piece is a polynomial. Polynomial is continuous, right? So the only possibility that this function might not be continuous is when those two pieces meet. Okay, they meet at the same point or different points. That's why we need to check when x goes to 1. So x goes to 1, they meet at 1 from the right, and you need to check x goes to 1 from the left. Okay. Who did I ask for? I don't remember. Okay, then start with wheel again. Okay. X goes to 1 from the right. Which formula do we use? The top or the bottom? The top, yes. So we plug in the top formula. A square root of x ln x plus b. Right, everybody? We plug in the top formula. And limit, so we plug in x is 1. Right, everybody? When we evaluate the limit, we plug in the number first. But if you see something weird, like 0 over 0, then you know there is a bad guy, and then you do something else, right? To cancel the bad guy. But here we plug in 1, we get a square root of 1, ln 1, and then plus b. What is ln 1? What? ln 1 is 0, yes. Oh, do you see we only get B? Yes. Okay. How about limit x goes to 1 from the left? Which formula do we use? Dylan. The bottom one. We get what? 5bx squared minus 3. And when you plug in 1, what do you get? Okay. So, do you remember we want to set them equal, but we also need to mention what is f of 1. So f of 1, you look at which part you have the equal sign, right, everybody? You see here has the equal sign. So this guy, the 5b minus 3, is also equal to f of 1. Okay? Everybody, I emphasize again. If you forget this, say this is f of 1, you will lose 1 point in the exam questions. Oh, because to show a function is continuous, you need the function value equal to the limits. Okay? So we want to find the number b such that this is continuous. So we set this equal. Set this equal. Then we have the left side limit and the right side limit equal. So the limit exists, but that's not enough. You also need the limit equal to the function value. So you have to mention they are equal to the function value. And why do we pick this? Because the equal sign is here. When x equals to 1, f of x equals to this guy. That's why we put f of 1 here. It's up there. So you look at which piece has the equal sign. Okay? then you use that formula to evaluate x equals to 1. Is that clear, everybody? Again, if you forget f(1), you lose 1 point on the exam. Yes. Okay. Let's see. Okay, so we get what? B equals 5b minus 3. Right? We set them equal. And how do we solve for b? Page. My F3, you mean? How do we solve for b? Get it by itself. Yes. So what operation do we do? So how do we get the b by itself? Yes, move the 3 to the other side and move the b to the other side. Okay, so both sides we're doing F3, right? And subtract b, right? So what do you get? Yeah, 4b equals to 3. Then what is b? 3/4. Okay, everybody? All right. Let's see. So this is part A. This is what we learned before. Now part B. Find the values of a, b such that the function is differentiable. Well, differentiable, that means we want the left side derivative equals to the right side derivative. Okay, so x goes to 1 from the right. Take the derivative. And the left side, take the derivative. We want to make sure they are equal. Is that okay, everybody? Once we make sure they're equal, then the derivative is the derivative exists. Yes. Okay, let's look at the right side. The right side, we use the top formula, right? So we get the top formula is a. What is square root of x? X to the 1/2, right? Ln x plus b. And we want to take the derivative of this. Is that okay, everybody? Okay, let's see. Let's make it bigger. Mackenzie, how do we take the derivative? Oh, let's do it slowly. Do you see this is a product? So we do product rule first. So when you do product rule, don't take the derivative now. You do first guy prime. So first guy prime times second guy plus prime, right? Oh, and also, do you see what's the derivative of b? What's the derivative of b? 0. So a and b, they are constants. They are like a number. X is the variable. Okay, so derivative of b is like constant, so it's 0. Okay, let's see. Oh, I need more space, so I move this down. And let's see here. Limit x goes to 1 from the right. Okay, still you, Mackenzie. What's the derivative of a x to the 1/2? Yeah, very good. And then we multiply by plus a times 1 over x. Yes. Okay. If we plug in 1, what happens? You see, it's 1 half a. Do you know 1 to the whatever power is 1? Is that true, everybody? 1 to the whatever power is 1. So x to the minus 1 half is 1. And you have ln 1 plus a times 1 and then divided by 1. Right, everybody? What's ln of 1?
0
Bless you. Yes, 0. So this is 0. So our answer is just A. Is that okay, everybody? Yeah, even though the derivative is hard, not simple, but when we plug in 1, 1 is such a nice number, so we only get A. Okay, everybody? How about the left side derivative? What is the formula of your left side? 5x squared minus 3, right, everybody? So write it down here. 5bx squared minus 3. By the way, please make sure to carry the limits all the steps. Otherwise, you will lose 1 point. Okay? So, I don't know, did you submit your exam 1 correction and wrapper? I remember many of you forget to write the limit. So, when you do the corrections, please look at the details carefully. Did you include the limits?
half a plus x everything.
Huh? Oh, because ln of 1 is 0. We multiply by 0. So that, yeah, that term is right. Okay, derivative. Gabby, what's the derivative of this? 10bx. And that's it, right? If we plug in x is 1, what do we get? If we plug in x is 1, what do we get? 10b, yes. Okay, everybody? So we set the left side derivative and the right side derivative equal to each other. So set them equal. Oops. So we get A equals 10b. But from part A, what was B? 3 over 4. Right, everybody? How can you cancel 10 and 4? What do you get? You get what? 10 divided by 2 is 5. 4 divided by 2 is 2, right? So what is your answer? Yes. That's why we get A is 15 over 2 and my B is 3 over 4. So that is the answer for this problem. Okay? So if this happens, then F is differentiable. Oh, part A I forgot to mention. So we should say if B equals to this, then F is continuous. Okay, so we answer like this. Okay, so in the next exam, you will have some problem like this. When you find the function continuous, the left side limit and the right side limit, you also need to mention one of them equals to the function value. Okay, but when you do the derivative, you just put the left side derivative and the right side derivative, and you just set them equal. Okay, everybody? Yes. So, yeah, please make corrections on your exams, and next Monday you have homework due. Okay? And next Friday you have what? Homework 7 and quiz, right? So you're gonna have 2 homework due next week. So yes. And don't forget that your homework you can do it multiple times until you get the perfect scores. Okay? So have a nice weekend. And yes. And have you registered, or can you register next week or this week? This week? Next week?